We are solving two questions in AC. That is, first one is NEET 2016 question, which says, which of the following combination should be selected in a LCR circuit for communication? So, first of all, how do you decide which has to be used, right? To use, we shall have a condition in such a way that loss of energy shall be minimum. For the loss of energy shall be minimum, the resonance circuit, LCR circuit, shall have high sharpness, in that resonance curve. To have high sharpness, the Q factor of LCR circuit shall be high. Right. So, we shall choose an LCR circuit whose Q factor is high. How can I get a Q factor? Q factor is 1 by R of square root of LC, where R is resistance, L is inductor and C is a capacitor. Just for example, if we take the case 1, option 1, Q factor in this case is 1 by R means 20, root of L means 1.5 by C is 35 micro, that is 35 into 10 power minus 6. If you look at the calculation further, that Q1 will be 1 by 20, 1.5, 10 power minus 6 becomes 10 power plus 6 divided by 35. That is 1 by 20, multiply this with 10, 15 into 10 power 5 by 35, where 5 3s and 5 7s. So, 1 by 20 square root of 30 by 7, 10 power 4 under the square root becomes 10 power 2. That becomes 100 by 20 root 30 by 7. 100 by 20 is 5. 30 by 7 is a little more than 4, right? A little more than 4. So, I am writing approximately 4, right, under square root. So, that becomes close to 10. So, like that we have to substitute for each of the options and see where do you get a high Q factor. It is noticed, if you do the calculation, for option C you will get a Q factor that is little more than 20, who is highest. So, that is the best option that we shall use, so that we will get the results that what we want, that is the maximum Q factor and less loss of energy. That is why we shall choose that. That is how we have to answer. So, to solve that, you need to know this concept that Q factor has to be maximum. So, loss of energy is a minimum. That is how we decide and choose the values of LCR in the LCR circuit. That is one problem. Let us solve the other problem that is given in NEET 2016. It says the potential difference across resistor, capacitor and inductor are 80, 40 and 100 in a LCR circuit. What is the power factor is? As we have discussed even in the previous problems, power factor cos phi can be found using resistance by inductance, where Z is inductance and as they are all in series in LCR circuit, current is same. So, in the place of resistance I can write V equal to IR, as current is constant, R is directly proportional to V. So, I can write V across resistor by V across the total circuit can be written, right. So, what is V across the total circuit can be root of VL minus Vc whole square plus Vr square, simply because inductor and capacitor are in opposite phase and to their resultant resistance is perpendicular to each other. So, for a resistor that is 100, for capacitance, for a resistor it is 80, for a capacitance it is 40, and for inductor it is 100. So, EL minus Vc means 100 minus 40, is it not? For a resistor it is 80, for capacitance 40, for inductor 100, right. So, whole square and Vr square is nothing but equal to 80 square, that is square root of 60 square plus 80 square. 60 square is 3600, 80 square is 6400, that is root of 10,000, and square root of 10,000 is nothing but equal to 100. That implies we can get the power factor as Vr is being found as 80, given as 80, resultant impedance is 100, 80 by 100, that is 0.8. So, the power factor in this case is 0.8. This is how we have to solve. So, all these problems are very much formula based problems. So, while you are handling with AC, knowing formulas is very important, right. Okay. Thank you for watching.